This lesson is on solving polynomial equations using synthetic division. Synthetic division is a special way to do long division that has a certain form. Now, the key to synthetic division, it only works when your divisor has this form, x minus c. Now, it's important that we find c correctly. So, I want to make sure that we understand what c is. C is the constant behind the subtraction sign. Now, I've got a little table set up. I'm going to put some numbers here. And I want to make sure we can find c. Well, the minus sign is in front of this 1, so c turns out to be positive 1. I don't like that. Positive 1. X minus 6 means c is 6. X minus 7 means c is positive 7. Now, sometimes it will be a plus sign in the middle. If it's a plus sign in the middle, your c is negative. C is always the opposite sign of what's in the parenthesis, of what's in the x minus c. So the c is the opposite sign of what's in the binomial. I need y'all to remember that. Opposite sign of what's in the binomial. Now, I want to take the same problem and I want to do it using what we call synthetic division. Now, synthetic division doesn't involve any variables until the very, very, very end. To do synthetic division, what you do is you take a little half box. On the right of that half box, you bring down the coefficients of your polynomial and the constant. Draw a little space here. You bring down the first number. Now, what's going to go in this little half box is c. Now, c comes from the binomial, and it's always the opposite sign. So, in this case, c turns out to be positive 3. To do the synthetic, what you're going to do is you're going to take what's here and you're going to multiply it by everything in the bottom row. Now, I said everything, not just the 2. So we're going to start with the 2 though. 3 times 2 is 6. Now what you do is you take the number you just get and you put it right above. And you combine those numbers together and we'll get a positive 3. Then we take the 3 out in front times this 3. Whatever we get, we put it right here. We'll get 9. Combine that together, we'll get negative 2. And then we multiply the 3 out in front times the negative 2. Put it right here, we'll get negative 6. Combine that together, we'll get positive 1. Now pay attention. The number at the end, when you do synthetic division, is your remainder. This is the same remainder that I got earlier. Now, the bottom numbers are the coefficients of a polynomial. Notice we started with an x cubed under the division symbol. We have to put the variables back with these 3 numbers. The first number will be the coefficient of an x squared. The second number is the coefficient of x, and the last number is your constant. You put the remainder at the end over your divisor. I'm going to highlight this. Now, this is the exact same answer that we got earlier when we did the long division. Let me back up and make sure you see that. 2x squared plus 3x minus 2, and the remainder is 1. 3x squared plus 3x minus 2, and the remainder is 1. You have to put the variables back with the coefficients and at the very end of that bottom row. The last number is the remainder. If you've got 3 numbers, that's a trinomial. If you had 4 numbers in front of the remainder, it'd be a cube, so on like that. But we're only going to do x cubes and x squares for right now. Now, I'm going to do a few more examples of this, and then we're going to talk about what some other stuff means. All right. Bring down the coefficients. Bring down the first term. Now remember, I got to figure out what's going to go here. Now the c comes from the binomial, and it's the opposite sign of what's the number is in the binomial. Got to remember this, opposite sign. Now we're going to take that number and multiply by everything below the line. So negative 2 times 5 is 10. Negative 10 goes right here. Negative 10 plus 3 is negative 7. Then we take the negative 2 times the negative 7, it goes right here. 14. Combine those together, we'll get positive 7. And negative 2 times 7 goes right here, negative 14. Negative 14. And negative 8 is negative 22. So that negative 22 is my remainder. So we're going to put the variables back with the numbers. This will be a 5x squared minus 7x plus 7 minus 22 over the divisor. Alright, so I'm going to do another example of the synthetic. Got to get used to doing this. This is in the next section too. Alright, we'll set this one up. Bring down the coefficients. Strange looking number. Alright, now, line. What's going to go here is positive 1. Comes from here. Alright, so we take the 1 times the 4, put it here. Combine that with that, we'll get 1. Multiply the 1 times 1 is 1. Combine those together, we'll get 4. Multiply the 1 times 4, we'll get 4. Combine that together and we'll get 3. Alright. The 3 is my remainder. I put the variables back with the coefficients and add the remainder at the end divided by the divisor. Alright. Let's do another one, just to be on the safe side. 5, negative 7, 1, 9. Now, what's going to go here? It's x plus 3. So what's going to go in the little box is negative 3. Alright, so we multiply negative 3 times everything below. Negative 3 times 5 is negative 15. Combine those together, we'll get negative 22. Negative 3 times negative 22 is 66. Add 1, get 67. Then negative 3 times 67 is negative 201. Combine those together and we'll get 192. Negative 192. That's the remainder. Now, we put the variables back with the numbers at in the bottom. And we write the remainder over the divisor. So one thing you've got to remember is if it's a plus sign here, it's a minus sign there. Sign changes. Now, I want to talk about something called the remainder theorem. Remainder theorem says if you're dividing a function, in this case a polynomial, whatever you want to call it, a polynomial, is divided by this. Now, it has to have this form, x minus c. We can find the remainder only by plugging c in the function. Sometimes I may want to know what the remainder is. I don't care about anything else, just the remainder. So instead of going through all the synthetic division, we could just evaluate the function for whatever c is. Now let's take this problem we had earlier. I said that c was negative 3. And when we did synthetic division on this, we found that the remainder was negative 192. That was the remainder. I want to use this remainder theorem to find that remainder. So we're going to take away the x. You know, this is normal stuff that we've done in the past. I'm going to put a negative 3 everywhere the x is. So we'll end up with 5 times negative 27 minus 7 times positive 9 minus 3 plus 9. 5 times 27, that's negative 135 minus 63 minus 3 plus 9. So I'll get 201, negative 201 plus 9, which gives me negative 192. So we found 192 by doing synthetic, then I also found 192 by doing what we call the remainder theorem. So sometimes we actually just want to know what the remainder is. We don't care about anything else, just the remainder. So we can use this shortcut. Synthetic's not that hard to do either. It may be easier instead of trying to plug all these numbers in and simplifying sometimes. I don't know. It just depends on the person, I guess. But this is the remainder theorem. Now, the remainder is important sometimes. I want to talk about remainder of 0. Remainder of 0 means something special. If we have a 0 as a remainder, that means this is, x minus c is something special. What we're going to end up doing in the next section is solving more complicated polynomials. And in order to do that, we need the remainder to be 0. When the remainder is 0, let me put if here. If the remainder is 0, that means this is a factor. And remember, factors are just multiple, things multiplied together. So what we're going to end up doing is solving by finding factors and then setting them equal to 0. Now, so here's something called the factor theorem. And it's based on the fact that something's a factor and the remainder is 0. Now, if this is 0, this is what I just did in that previous example. We plugged the c in and we found the remainder. So remember, this is the remainder theorem. if we plug the remainder, if we plug the c in and we get 0, then that means this is a factor. So it's important to know the relationship between factor and 0. If I plug a number in and I get 0, then that means x minus c is a factor. If I am told x minus c is a factor, that automatically means the remainder is 0. And I'm going to show you an example that goes back to chapter 2 when we were solving quadratic equations. All right. Now, so we just got to remember this. Try to remember this. If I know the remainder is 0, I automatically know this is a factor. Now, the factor is a binomial. The c is a constant. So factor is the binomial. If I know this is a factor, I automatically know my remainder is 0. Now, let me give you an example. Suppose we had x squared minus 6x plus 5 equals 0. You know, when we factored this and we solved it, when we solved it, we always set the x is equal to 0. The factor is equal to 0 and solve for x. So these are the solutions to this equation. Now I want to show you something. I want to come over here and I want to take and I want to do this. I want to show you based on synthetic division. Suppose I wanted to divide this into this. But I want to use synthetic division. I want to show you what happens. Alright, so the number that's going to go here is positive 5. Now, bring down the first number, of course. Multiply the 5 and the 1, and we get 5. Combine those together, we'll get negative 1. Multiply 5 times negative 5, we get negative 5. And we get 0. Now, look. This is a 0. Because that's a 0, I automatically know this is a factor. Well, we had already factored it out, so I already knew that was a factor. And because this is a factor, I could automatically say, I know my remainder is going to be 0. Same thing here. Since x minus 1 is a factor, the remainder would be 0. So it's important to know the relationship between factors and zeros. The factor means the remainder would be 0 if I did synthetic division. If I know something's a 0, then I can work backwards to find the factor. Alright, so I want to make sure that we understand that. So let me come over here and I'll draw a little table. And on one side I'm going to put factor. And on the other side I'm going to put 0. Now, if I'm told x minus 4 is a factor, that means 4 is my 0. If I'm told x plus 6 is a factor, negative 6 is my 0. If I'm told 7 is a 0, x minus 7 is a factor. If I'm told my 0 is negative 12, the factor is x plus 12. So we need to make sure that we remember the relationship between the factor and the zero. And this is going to be important whenever we start doing the synthetic division and stuff like that. Now, we just introduced the word zero. Zero means my remainder is zero. The following words all mean the same thing. You're used to this word, solution. When we're solving quadratics, we're finding the solutions. Well, another word for the solution is a root or a zero. They mean the same thing. If you saw the phrase, or if you saw the instructions that says find the zeros, that just means solve. Solve for x. If you see the phrase find the roots, that means solve for x. That's all that means. So those three words means exactly the same thing. Now, either one of them will be used in the problems, so we have to know that they mean the exact same thing. Now, I'm going to give you some examples from the book using different methodologies, or different ways of saying the same thing, and I want to see if we can figure them out. Now, here's a problem. It says solve the equation (2x cubed minus 5x squared plus x plus 2 equals 0), and I'm given that x minus 2 is a factor. Here's where the relationship between factors and zeros come into play. We're going to use synthetic division to help me do this. But I've got to figure out what's going to go right here. Now remember all the problems I did earlier. It gave me x minus something. It gave me the binomial x minus whatever. In this problem, what is the number that's going to go here? Well, since it's x minus 2, the number that goes here is positive 2. Now, something else. Since I'm told this is a factor, before I even work the problem, I know my remainder is going to be 0. Based on the fact that it's a factor, my remainder will be 0. You'll see why in just a second. Now, let's use synthetic to do this. Bring down the 2. 2 times 2 is 4. 4 goes here. Combine those together. Negative 1 times 2 is negative 2. Combine that together, we'll get negative 1. 2 times negative 1 is negative 2. And we get a remainder of 0. Put the variables back with the numbers. So we'll have 2x squared minus x minus 1 equals 0. This time we're doing the equal to sign because we're solving. Now, let me make sure that we understand this. This 2 is a solution. Which is also called a root. Which is also called a 0. since it says solve the equation, what it wants us to do now is go factor this piece and solve for the other two solutions. I'm just going to go ahead and factor it for you. So you're going to end up having to factor. And we're going to get -1 plus 1 here. This goes back to chapter 2 where we were solving quadratic equations. Solving this one, we're going to end up with x to be -1/2. This one will be x will be +1. Guess what? These numbers are called zeros. Or roots. Any equation, any solution to a quadratic are your zeros. So this problem has 3 zeros. 2, -1/2, and +1. When it says solve the equation, this is what it's talking about. Using synthetic division and given the information to find the quadratic, and then you want to factor the quadratic. Let's do another one. I want to solve 3x cubed, plus 7x squared minus 22x minus 8 equals 0. This time I'm given that, oh Lord have mercy, I don't like this. Let's do given, I'm going to change it up a little bit. Given -4 is a root. Now, what does the word root mean? It means the same thing as 0. It's telling me up front what to put right here. What's going to go in this little half box is this -4. And bring down the coefficients. And then we're going to go use this to find the quadratic, and then we're going to factor and solve the quadratic. Bring down the first number. 3 times -4 is -12. Combine that, we'll get -5. -4 times -5 is +20. Bring that down, we'll get -2. -4 times -2 is +8. And we get 0. Now, I already know it was going to be 0 because I was told it was a root. Root means 0. Means remainder of 0. So, put the variables back with the numbers. That's going to be a 3x squared minus 5x minus 2 equals 0. Now we're going to go factor this. Use the slide and divide method. This is what you'll get. Now, I'm going to go ahead and solve these for you. Well, let's just set them equal to 0. Solve for x. When I solve this one for x, we'll get +1. When I solve this one for x, we'll get, move the 2 over and divide by 3, +2/3. Which means this, and make sure I factor that right, y'all. Whoops, I factored that one. Hold on, y'all. Back it up. Let's back this up. I got the sign wrong. See, even I make a mistake sometimes on the factoring. It happens. Got the numbers in the wrong spot. -2 plus 1. There we go. Now we set them equal to 0. Just make sure you get the signs in the right spot. It's easy to mess up. And this will give me -1/3. Now we go back to what I said. This, whoops. this and this are all roots. And they're also called zeros. And they're also called solutions. So you've done the bottom part before. Now we're getting an extra step where we're solving higher order polynomials. Let's solve 2x cubed minus 3x squared plus 11x minus 11x plus 6 equals 0. And I'm given that negative 2 is a 0. So this time I'm told something specifically is a 0. And what does 0 mean? It means solution. One of my answers to this problem will be negative 2. Now, when we're doing synthetic division, we have to have a number that goes here. Well, I'm not given x minus a number. I'm specifically told that a number is a solution, is a 0. This number is what goes right here. I don't change the sign because it's given to me that it is a 0. A 0 means a solution. The number that goes here is always a solution. Let me back up and show you. See over here, the number that was here is a solution, which is also the same thing as a 0. So it's telling me something's a 0, so that's what's going to go here. So know the difference between being given a factor and being given a 0. The 0 is the number you use. If it's a factor, you change the sign of the number. But anyhow, let's go do this one. Bring down the 2. Negative 2 times 2 is negative 4. Combine that together. We'll get negative 7. While I'm here, don't forget, since it tells me negative 2 is a 0, I'm going to get a remainder of 0. Now, negative 2 times negative 7 is positive 14. Combine those together, we'll get 3. Negative 2 times 3 is negative 6, which gives me my 0. So, I automatically know that's one of my answers. Okay, let's put the variables back with the numbers, and then we're going to go factor this and solve it. Okay, when we factor this, I'm going to go ahead and factor it for you. You can use the slide and divide method to factor this. We want to get a 2x and an x, minus 3 and minus 1. Now, let's set those equal to 0 and solve for x. So we're going to move the 1 over, it becomes positive 1. Then we divide by 2, and we'll get 1/2. So this is one of the answers also. Now, we're going to take the x minus 3, set it equal to 0. So when we solve that, we'll get x to be positive 3. So this is one of the other answers. So we have 3 answers. Okay. We have negative 2. Whoops. Let me back that up. So we have negative 2, 1/2, and 3. So these are my solutions. Remember, they're either called zeros or roots. Okay, let's put the variables back with the numbers, and then we're going to go factor this and solve it. Okay, when we factor this, I'm going to go ahead and factor it for you. You can use the slide and divide method to factor this. We want to get a 2x and an x, -3, and -1. Now, let's set those equal to 0 and solve for x. So we're going to move the 1 over, it becomes +1. Then we divide by 2, and we'll get 1/2. So this is one of the answers also. Now, we're going to take the x -3, set it equal to 0. So when we solve that, we'll get x to be +3. So this is one of the other answers. So we have 3 answers. Okay. We had -2. Whoops. Let me back that up. So we have -2, 1/2, and 3. So these are my solutions. Remember, they're either called zeros or roots.